What is up, most distinguished patrons of this channel? So today we are going to be dealing with beveling plates and whether or not it makes a difference in the strength of what you're welding and everything to do with that. So let's get into it. So without a doubt, the most controversial topic that has come up on my channel consistently is beveling. And I can't count how many comments that I've gotten since I started this channel on brake tests and weld tests I've done where people always say, well, that's stupid. Nobody welds 3/8 plates without beveling, or always bevel. And it's just a controversy that won't die. And that's the point of testing it in this video. Now, right away, I got to tell you guys that regardless of what is found in this video or what other YouTuber says about beveling or welding in general, you have got to get out and test your own welds. You cannot rely on what somebody else gets is a magical sauce to where you get the same results. You have to test, and it doesn't matter if you're doing brake tests, cut and etch, do something. If you're welding a higher strength or something that requires high strength, you can't just put a weld down and say, yep, it'll hold, it's good, when you have no concept of whether or not you're getting any fusion with your welds. Like, your weld might look good on the surface, but underneath it could be completely trash with no fusion. And I found that out on multiple different videos on this channel that I've done where it looks good, but it's not. That's a common theme with welding, and that stresses the importance. You have got to test stuff that you're welding with your machine and your capability to understand if you are getting the results that you should be to weld at higher strength, okay? Now, with that said, we're going to be doing a ton of different tests dealing with bevels. So we're going to do different angles, we're going to do gaps, we're going to do bevel and a gap, we're going to do lower settings like what you could do with a 140 amp MIG welder. We're going to look at that as well. So before we get into the actual welding part, we need to do some book learning because there's a lot to this, and if I don't cover this, there's going to be a lot of confusion. So let's get into that. There are a couple key terms that we need to discuss right away, and it has to do with bevels and angles. So when I say bevel, I'm talking about basically grinding or machining off the edge of a plate to where you have an actual bevel. So this would be more or less a steep bevel, same with number 3. A less steep bevel would be like number 4, and then a bevel with what's called a landing would be like number 2. The landing is basically the material that's left that's flat of the original plate edge. Now, in most welding, say like pipe welding or a open root butt joint, you're not going to have much of a landing on that. So you're going to be down to knife edge or maybe like a 1/16 landing or about the thickness of a dime. And by having a knife edge, you have to run a tighter gap or you can blow that edge off. By having a thicker landing like a 1/16, you can run a little bit more of an open gap between, say, two butt joints or a butt joint, and it allows you to not blow the edge out. So that comes down to a lot of personal preference, and it depends on what position you're welding in and what you're welding on. But for the sake of what we're going to be doing today, we're going to be testing fairly steep bevels with a knife edge. We're going to test bevels with a landing. We're going to test shallow bevels. We're going to look at all of that. Now, there's a couple other key things that we need to talk about regarding this. And it has to do with weld penetration. One of the things people are confused about is they think that if you just magically bevel something that somehow you can melt more of it. And this video is going to prove that that simply isn't the case depending on what you're welding. Now, if you're welding a open root pipe or butt joint where it looks like this and you have two beveled angles and it's knife edge or near knife edge, yes, you can weld right through that with almost a sparkler. It takes very little heat to melt that and fuse that. The problem is that us at home and most of what you would probably weld, unless you're welding on pipe all day, is not open root butt joints. Commonly, we weld fillet welds or lap welds, which are more or less like this. And one of the things, and I've tried to be pretty specific when I respond to people regarding this, when they say beveled is a solution, is that beveling increases penetration on joints like this tremendously. When you have a fillet weld or a lap weld, but we'll talk about fillet welds, and you bevel one member of the two-part member and then weld on it, you might see increased penetration fusion into this top plate. But what about this right here? This is not beveled, it's not thinned down, and in the case of like 3/8 plate, which would be something that a lot of people say you should bevel, you're not gonna get increased fusion into the thicker plate. If anything, like I said, you're gonna see a weld nugget that would penetrate and fuse more into here because it's thinner, and then less into here. And that's what I'm predicting is going to happen in this video. But it's something that a lot of guys just flat out don't think of, because how are you going to get more fusion into thick plate by only beveling one of the two? I don't know, and we're going to find out if that's the truth. The other thing is, in theory, you could grind this whole thing down and then slam this in here and weld it, and that actually might work, but who does that? Nobody. I know I don't, and I don't know anyone that does. And that's why, like this, to me, I think the beveling question, it really depends on what you're welding on. The other thing to consider too with beveling is when you weld just a standard, let's draw it right here, and you just weld a normal fillet weld with a straight 90 corner, not beveled. When you weld on this and put a weld here, it's going to pull this way, okay, but not that bad. When you start doing way bevels, like way far in here, the amount that this is going to warp, in my opinion and in my experience, is going to be more than just doing this. So you got to watch that if tolerances or how something is angled when you're done welding it, you can implement quite a lot of bending and twisting of something by doing this. So that's another thing you got to worry about. All right, let's move on. So the key things that we're going to test in this video are: one, welding thick plate with a 140 amp MIG welder. Is it possible to do that with a bevel? Because people have suggested it, that all you need to do is bevel and it solves the issue of the lack of fusion. Two, it always boosts strength by beveling. Three, increases penetration. Four, wide bevel is better than a narrow bevel. And five, gap is better than a bevel. And we'll test some other things that we'll go through and mention, but these are the key things we're going to hopefully answer. Now, with that said, I got to be upfront and honest with you guys. Two things. One, this is going to be a small control set, and this is not absolute guaranteed results. If you follow what's in this video, you'll get the same results because it is a small sample size. Now, when you see why certain things happen, I think you're going to understand the differences between all these bevel angles and all of this, to where you can kind of make accurate predictions to what would happen on your own. But again, you have to test your own welds to understand what's going on. And two, again, I'll be upfront and honest. I did this test already fully, and the video footage to it got taken when my camera got stolen. Well, I got a new camera now, and I'm redoing this whole testing. So the good news is that I do have a bigger sample pool. The bad news is that, well, I don't have any video evidence of the previous tests, but I do have an opinion on what happened, and I predict that very much the same is going to happen with these that happened in that. And if that is what happens, I will tell you. If it's opposite of what happened in the previous video, I will tell you that as well. So the sample size is bigger than what you're seeing now. Now, a third thing as well that I'll mention, this is a very difficult test to do 100% under controlled circumstances. Ideally, I would have a track torch or something for the MIG gun, and I would set it for the speed, and I would take myself completely out of the picture on this, because small change in travel speed can change the amount of weld metal deposited and can completely change the results. And I'm only going to be doing single passes on all this metal, whereas under normal circumstances, you would do multiple passes. So we're only looking at essentially the root pass. And again, Very difficult to be consistent on this, because when you weld a bevel, you have to deposit more metal and change your travel speed slightly to get it to work, because the way the weld pool works is completely different than when you're welding to a 90-degree corner. So I'm going to do my best at this to do a good job, but there will be variables. Again, do this on your own, test your results, and then you can build confidence that way, knowing that you have what you should. All right, enough said. I'm going to get to beveling some of these, and then we're going to weld them all up. I have 4 of these test welds set up to break, and the first one is going to be our control. This guy was done with no bevel, nothing, just straight in, and a drag angle. All of these were done with a drag angle, which generally does increase penetration. So let's see what this guy breaks at. (97.7), pretty typical, and we don't have much root fusion due to all of these being done with the short arc process. With multiple passes, it would be higher, but again, we're comparing single passes. And the main purpose of this isn't so much to compare the results here, it's to look at the penetration inside of the weld is really what we're here for. But I'll throw this in so we all have an idea. Now, this guy is a wide bevel. (120), it cleared itself, sorry about that. Slightly higher, which is promising. This guy is a knife edge bevel, so this would be a wider bevel, but done to knife edge without a landing. This one had a landing on it. (139), again, it cleared itself. And now this is a narrow bevel. Let's break that. (199), so pretty good result there. All right, I'm gonna finish breaking all these off camera, and then we're gonna set up and look at the other ones. We're gonna break those. So now we're going to brake test the final 4 of these. And of course I was an idiot and welded this one on backwards. So I'll have to reverse this in the vise to do that one. Not a big deal. Hey, shit happens, right? So this first one is a medium bevel. So halfway between a very wide and a very narrow bevel. Let's break this. 131.9, of course it already reset itself because it's a Harbor Freight tool. Now this next one was welded with a gap rather than a bevel. So to put a number on it, I would say an 1/8 inch within an 1/8, maybe slightly like a 64th under, so an 1/8 inch, maybe a little bit less. (144.3), so not too bad there. Now I'm going to reverse this in the vise so we can bend that one. So I got this one set up and I have clamps on the back to keep it from bending forward. It should work. This is the control for a 140 amp MIG weld without a bevel. And 71.9. Pretty abysmal performance. All right, I'm going to rotate it again and then we're going to bend the beveled plate. So this is the beveled plate with 140 amp weld on it. Let's see if it breaks higher. 83.4, little bit higher. All right, let's go and break all these up and look at the results on the welding table. So we got all of these that were done with settings that are appropriate for around 200, 210 amps. We're going to look at the lower amperage ones completely separate. So let's start out with the control and the wide bevel. This is a control weld. You can see it had some fusion at the start. As it carried heat, got a little bit better near the end. In the middle of it, we can kind of see bits and pieces of that original plate edge. Not really the best penetration by any means there, and this is typical for short circuit MIG. There's really no way around this. You got to switch processes to like spray arc. Now, the bottom plate is quite interesting because when you look here, very little bit into this plate at all. So not only did it tear off here, but the width of the fusion there very limited. Now this weld goes from about right here to right here, so clearly a lot of it didn't even fuse on there. Now this weld is actually the smallest out of all of them for the most part, so that's part of the reason why it broke at probably a little bit less than it should have. But let's face it, guys, you're just not going to get much fusion when you run straight in a corner like this with the short circuit process. Spray arc is by far better. Now let's look at the wide bevel. So the wide bevel, as I expected, did not break down that inner landing at all, and you're simply not going to with the short circuit process. As that wire hits and starts depositing metal, you have to weld through that weld pool in order to break this down. Well, so much of your heat is pulled off into this top plate and into the bottom plate that there isn't anything left for that wire to basically melt in here. The only way you're going to break that down would be to leave a fairly big gap in there with that wide bevel and then weld it. That would work. But if you just have it tight, even that thin of a knife edge, and it's not even knife edge, a little bit of landing, is not going to break down. So the root fusion really isn't going to be better with it. However, our depth of weld is going to be better because it's further into the plate. Now this is actually a little bit bigger of a weld than this guy, which did also help it a little bit in the strength department, and that's kind of one of those things where it's very hard to be completely consistent and fair. However, this did perform better than it did previously for the control. One thing, you look at these two, see how much more bit into the bottom plate? And part of that could be the angle that the wire was coming in, put more heat here, but that's a better result. When you start seeing stuff like this, you got issues. This nice and wide, you knew it bit in some, but it completely broke off the bottom plate, likely because it had more fusion into the top plate, which would be expected because the bevel is going to melt this easier than this because of the heat input. All right, let's look at the medium bevel and the narrow bevel. So the medium bevel, again, complete lack of fusion near the landing, and you're simply not going to get it like I said earlier. The weld on this is actually quite a bit bigger than the control weld for the metal deposited, and you can see I almost made it out flush. I really wasn't intending on doing that, so that did help the performance of this a little bit. But again, not stellar here, and that isn't a good sign. Now, it broke off this plate quite a bit of the material. It's not very deep. The fusion there isn't really going to be that good anyways because of the 3/8 plate. Remember, this is unbeveled. Results here, I would say better than the control, but not really. Again, most of the strength of this came from the fact that we put a bigger weld down. Now the narrow bevel, if you look right here, there's completely untouched half of that bevel because simply it's not going to melt further in than what the wire can get through the molten puddle at. So completely untouched. It did bite really good into the plate here, as well as you can see it broke off of this plate more so than here. It likely bit very well into here, and this posted very good numbers as well. So in the sake of testing purposes, this performed better than I would have thought. However, once again, putting a full-length bevel on it like this is not going to be utilized without running a gap, a wide gap between the plates plus the bevel. So interesting there. Let's move over to the knife edge and the gap. So this knife edge bevel did not break down that at all, and that's because we were not running a gap at all. That's the only way you're going to achieve that, and that's one thing we can be certain of on here, is that just running that bevel is not a guarantee full fusion weld. You're going to wind up with stuff like this. Now again, it broke more off of the bottom plate than the top plate, and it's not very far penetrated, but it is better than the control by a little bit. And remember guys, gun angle and everything can change the effect that this has. If you were to favor the top plate far more, like you come in with an angle like this rather than an angle like this, you could end up fusing almost everything to here and have very little strength into this bottom plate. So be mindful of your angle of your gun, or if you're stick welding, the angle of your rod. Let's look at the gap. Now the gap performed really well, better than some of the other ones, and it clearly stuck to the bottom plate very well. The top plate here, it tore quite a bit out of it, which I would say is a good result overall. And we did not achieve more than halfway fusion in that, because remember, this just had a gap and no bevel. Well, it penetrated somewhere around about 1/8 and fused that, and that was it. When you look here, you can see there's clean metal down in here where it wasn't even obviously touching anything because of that gap, and then it broke off here. So this, again, fairly high strength, and the reason for that high strength, really, just like this guy, the medium bevel, the more that you can get a weld to fuse to both the top and the bottom plate, the better your strength numbers are going to be. Anytime you have poor fusion into one of the two plates, you're going to have issues where it's going to want to pull off of that weaker penetrated plate. All right, that's enough of this. Let's look at the 140 amp. So I brought out the control on the higher amperage to the control at 140 amps to compare and contrast right away. So you can see on this 140 amp, there is no breakdown of that root whatsoever, which is going to cost us significantly in strength. And when you look at the bottom plate, the fusion is even worse. So right here, it gets pretty narrow on this. That's not good, but here it's even more narrow with more of the polished plate edge showing. It's not a huge difference, but it's there. So this broke at lower values despite having similar size and weld, simply because of the lack of root fusion. I mean, there's none whatsoever, and there's a little bit here. A little bit will go a long way on this. Now, when you compare to the beveled plate, which obviously did increase slightly in strength, this guy, even worse breakdown of the edge. You got what essentially internal cold roll here. I mean, there's a cavern so dark under there you could hide bats or gold bullion in there. And interestingly enough, we do have a wider area of fusion there, but that could be just due to travel speed. There's more metal here deposited than on here, so I likely went a little bit slower. Again, all variables that are difficult to control. My takeaway, at least from this, is that beveling it slightly increases performance, but compare the results of each of these for breaking to any of them at higher values. So no, beveling is not an excuse to use a 140 amp MIG welder to try and weld thick 3/8 plate. You get far better results using hotter settings. All right, let's go look at a cut and etch. So we have the cut and etch of a medium bevel here. And as expected, absolutely no root fusion way back in here, and you're not gonna get it, as I said. We have better fusion into the top plate. If you see where this line is, we have penetration past that line in the top plate, which is to be expected because it's beveled and it's thinner, less mass to pull the heat out, better fusion. The bottom plate, which is unbeveled, has a complete straight line, which is not really desirable. And when you look at this, it's basically just sitting on the plate. Now, these broke at decently high numbers, but you don't want to see this, generally speaking, in a weld, because if you look right here, there's a complete lack of fusion there. It looks like a crack. It basically is just sitting on that plate. That gives a great place for a weld to start tearing at when you have that. Very undesirable. So based on what I'm seeing here, although it breaks at a fairly high strength level, this beveling is no solution to gain fusion beyond a certain point, so it's not a cure-all. Very interesting stuff. So let's go through this list and determine if they're fact or myth based on our test results. 1, you can weld thick plate with a 140 amp MIG welder simply by beveling it. I'm going to say busted. No, you should not be welding a 3/8 plate with a 140 amp MIG welder. Did it increase the strength? Yes, it did by a little bit, but is it worthwhile using that, and does it make it magically safe? No. And the issue you would have with a 140 amp MIG welder welding that thick a plate is that maybe one will hold, maybe one won't. But the performance, extremely subpar. Don't do it. And it doesn't matter bevel or not. And it doesn't matter if you preheat the plate or not. I did a video on that a while ago, and preheating is very little help, to be honest, overall. So no, you have no business welding that thick a plate multi-pass with a crap root with 140 amp MIG welder. So busted. 2, always boost strengths. This is plausible. And I say plausible because you guys got to remember the angle that you have your gun and where that wire hits and where that weld pool is will drastically change the performance. And that's why I can't stress enough. I know I'm beating a dead horse here. You have to test what you're doing. I do not weld like you. You do not weld like me. Your machine is not mine. I have adjustable inductance on my welder. Maybe you don't. All these things will change the result of the test, and you need to test your setup and your skills to determine. So always boost strength. Just beveling something, you might see higher strength numbers because, well, for one, in this test, the welds were thicker. That was a contributing factor, but it's too many variables to determine this as facts. So it's possible, but test. So we'll put that, I'll still cross it out. Increases penetration? No, that's a myth. Absolutely a myth. I'll cross that out. What it does is it increases the amount of weld material that you have. It does not increase fusion. As you saw, the standard short arc weld on a normal fillet weld that's unbeveled barely bit in. Well, guess what? It doesn't magically bite in because it's a knife edge bevel. Now, had we run a gap, it would have likely broke down that edge a little bit, but it does not increase penetration. You just have more weld deeper into the metal, so that's a myth. Now, a wide bevel is better. Now, this is kind of a tricky one because in the testing I did before this video, I had a little bit more variables in my test results, and some of that was simply I was less consistent, so I tried to make a lot of effort to make similar size welds to try and make it a more apples-to-apples comparison. But I can tell you the wide bevel is better. Generally speaking, the thinner your top plate is on a fillet weld, the more fusion you're going to get into that. But it does not change how much fusion you have into the bottom plate. So the performance that you have will be quite variable, but generally speaking, I would say a slightly wider bevel will prove on a multi-pass to be a little bit better than a narrow bevel. Again, variables. You don't want variables when you want predictable results. It's like, do you want 2 or 3 variables to worry about or 30? Well, guess what? The fewer the better. So wider bevel's better, plausible. It really depends, though. It didn't really show up too well in this test, but again, you will gain more fusion in the top plate that's beveled. So we'll just cross it out. Gap is better than a bevel. This, again, it all depends. We saw good results running a gap. Part of it was that I put more metal down than, say, without a gap and just a straight 90-degree fillet. But again, I would say that this is not really, it's give or take. I would say more or less a myth. It is an increase in depth of fusion by a little bit, but is it better than a bevel? Hard to say. I would say that if you're going to do anything and you don't want to bevel something, leaving a little gap will likely help a little bit. Again, depends on what you're building, though. That this is, again, really dependent on the situation. If you want to create the strongest fillet welds. Beveling is part of the picture, but it's not the end-all be-all. This weld right here is the typical result we saw today, where we have a bigger throat depth if I were to fully weld those out to the face, because, well, we're putting metal and we're fusing it back in here where you would never achieve fusion on a normal fillet weld. So that can be a benefit, but what we saw today is this little area back here that I'm coloring in has no fusion. So is this as strong as it could be? Absolutely not. Now, a typical fillet weld, if you only weld one side, you end up having to oversize that weld to compensate for the fact that you do not have any weld material on the back side of it. So if you find yourself in a situation like this where you can't weld the back side, a oversized fillet weld may be acceptable to get your strength that you're losing by not welding the back. Now that comes with a lot of drawbacks, one of which is this is going to flex and bend and shrink and move on you, so that sucks. So this is, situational dependent. Now it's also possible on a fillet weld, if you were to run a knife edge or slight landing and in a gap between it, and you were to basically weld fully through where you reinforce the back and then weld it all the way out to the face, you can have a full strength fillet weld here with welding it from one side only. So if the back is inaccessible, this would also work. This takes the most skill, okay? Now, another solution would be what's depicted here, which is simply to put a weld on both sides of the plate, and this is actually drawn kind of a bit ridiculous. You wouldn't need a 3-pass weld on both sides depending on how thick a material it is. But this, if you have access to both sides, simply welding both sides will give you the highest strength with the least amount of dicking around and worrying about having proper fusion. So the truth is that beveling is part of making really strong welds and joints, but it's not the solution in all cases. And unless you're actually achieving fusion, you're not getting the most out of it. So again, should you be in the habit of doing it, it can help out, but it's not the end-all be-all, and it's always important to test to see where things are at. There's one more thing I wanted to mention too. I did all this with short circuit MIG. If you think that stick welding would have better results, the truth is that it's not really any better, especially with 7018. And I'll put a picture up right now of a 7018. Basically all welding processes have the same issue at lower amperage, and that is achieving any kind of penetration and fusion is rather difficult in thick steel. So stick is not the end-all be-all in this. Not to mention, when you start dealing with really odd bevel sizes, what'll happen is, and I'll depict it right here. So this is the bevel. Your stick electrode may be this wide. Okay, this is obviously not drawn to scale. And what happens is that you effectively get a really long arc gap in here, and you can create undercut and slag inclusions, and the rod runs like crap, and you get arc wandering. So stick welding bevels, it's super critical that your bevel is wide enough that your rod fits in there to where you don't have a massively big arc gap. So beveling, there's a lot more leeway with wire processes because of how thin that wire is than there is with stick. Stick, the performance of this video would have been all over the map depending on what the bevel angle is. So the variables matter even more for stick. So with that said, I think I covered this good enough. You can learn a lot by doing your own tests and doing all of this, and this will hopefully give you a better idea of what's going on and maybe what you should do on future projects. So with that said, thanks for sticking around, guys. Until next time.